So we are going to be looking at a whole new topic on trigonometry, and we're going to build that up. We'll be looking at some trig equations in a lesson or two's time. But there's one really important new idea here that we are going to introduce before we get to any of that. And that's to think about how we measure angles. Now, as your starter task, I gave you these three sectors to work with, where I've given you the arc length and I've given you the radius, and you were trying to find the missing angle. I've laid out the first bit of working here, so I've used the arc length formula, I've put in the numbers I've got. Rearranging that should have got you that the angle equaled 57.2958 something degrees. And you should have got that for all three of these sectors. Now, that is really important because that means if I make the length of the radius also the length of the arc length, I get that same angle here every single time. Because mathematicians like this connection, which connects between the radius and the arc length, we call this a very particular thing, which is 1 radian. So we can actually measure angles in circles not by some arbitrary number like 360, but by asking how many radiuses around the outside of the circle would I need to go to get an equivalent angle to the one we're looking at. So it's quite a natural way to measure angles, and actually it's mathematicians' preferred way to measure angles. So as soon as you get into more complicated maths, angles are pretty much always measured in radians rather than degrees. Degrees is pretty arbitrary. 360 degrees in a circle is just largely because a few people in history really like the number 60, and it could be divided by lots of stuff. So we are going to talk a little bit more about this idea of radians, and we're going to build that up. So if we have a circle, we're saying 1 radian is if I take that radius and I wrap that radius around the outside, then the angle here is 1 radian when this bit here around the outside is the radius of the circle. So if this is the radius and that's the radius, 1 radius going around the outside is 1 radian of angle. But we have a nice little formula that tells us the circumference of our circle is pi times diameter, but diameter is just 2 radiuses, so we can rewrite that as 2 times pi times the radius. So how many radiuses fit around the outside? Well, 2 pi of them do. So that means a full circle here is 2 pi radians. So if I do a full turn all the way around, the angle that I've turned through is 2 pi radians. Now you could write that down as a number, you could write that down as 6.2 something, but we normally leave it, the exact value is 2 pi. Well, if the whole way around is 2 pi, we're counting this as 0 degrees as well, whole way around is 2 pi, then halfway around our circle must be pi, or pi radians. Well, if halfway round is pi radians, that means that 90 degrees, or a quarter of the way round, is pi upon 2 radians. And down here, we've done pi radians, we've done another half. So that's 3 halves, or 3 pi upon 2 radians. So there's a couple of really key values coming up. If I do a full turn, that's like doing 2 pi radiuses, or 2 pi radians of turn. If I go halfway, that's pi radians. 90 degrees is the same as pi over 2 radians, and 3 pi upon 2 is the same as 270 degrees. So it might be quite useful to have a little table of some of our key and most common angles that come up. So we're going to say 0, let's have 90, 180, and 270, and 360 degrees. So these are all degrees, and these are all radians. So if I've turned nothing, I've also done no radians. If I've turned 90 degrees, that's pi upon 2 radians. And if I've turned 180, that is pi radians. 270 is 3 pi upon 2 radians. And 360 is 2 pi radians. So that is a useful, handy little guide to some of the really common angles you're going to see. In fact, there are a few others that we'll add to that as we go on. And I'll talk more about those a bit later. But there's a starter. 360 degrees, our full turn is 2 pi radians. Half a turn is pi radians. And we're going to build a whole understanding of radians off that. You will notice as I'm going through, I'm not putting any units here. So that we'd have the little degree symbol normally. When we do radians, often it is assumed, if I give you an angle with pi's involved, it's in radians. You will sometimes see a little rad written after it, meaning radians as well. So in the next video, I'm going to show you how to convert between degrees and radians for some less nice angles than these. And then I'm also in the third video going to show you just what the trig graphs look like if we label up their axes with radians, which is something you're going to have to get used to doing. I will also show you in the third video just a little bit of information about how we can use our calculator and use it with radians.